Good morning. Today I'm going to finish our slide set on the decision process. However, what is in this recording will not be contained on your second exam. Rather, I'm going to push it off to the final exam. So all of the information contained in this slide set will actually be contained on the final exam. In this slide set, I'm going to begin by talking about the work of Fischman, Christina, and Anson. You'll remember that Henry published his memory drum theory in 1960 with one of his students, Donald Rogers. At any rate, in 2008, Fischman, Christina, and Anson published a paper called Memory Drum Theory's C Movement, Revelations from Franklin Henry. You can see from reading this abstract excerpted here that there is a major error in the memory drum theory, and that is that the way that the C movement is described, that's the most complex of the three movements, cannot actually be, that pattern cannot be displayed by any human being. It's not possible. When Fischman began a letter writing campaign with Henry that lasted approximately 20 years, Fischman brought this error to Henry's attention, of which he was not aware. Henry then admitted to a mild form of aphasia, which means that he wasn't able to get his words together to describe what he wanted to describe, and that was actually the error in the Henry and Rogers paper. So the point here is that replication is extremely important because this major paper that has the most citations of all kinesiology papers that are published in the Research Quarterly for Exercise and Sport for almost 90 years has a major error in it. Isn't that amazing? Well, we were talking about the limited capacity of the decision process and particularly of short-term memory. Some have described this as single channel processing. In other words, we can only process a limited amount of information at any given time. This has also been described as the bottleneck in the system. You could see here I have a bottle with a faucet that's turned on. At this point, you can see that the bottle is full, and therefore the idea of the bottleneck in the system is that once there's too much water or too much information in the system, the information actually flows out of the system rather than getting into the information processing system. So we have to be aware of how much information, or in this case, water, is being presented because we want the water to get in the bottle rather than flowing outside of the bottle. Also, this is reflected in Welford's model as the gate. Note that if too much information is going from perception to decision, Welford hypothesized that there's a gate in the system that then creates a stopgap so that the information that is moving through the system earlier can pass through before new information can come into the system. So today, really, I want to focus our attention on what's called uncertainty. And uncertainty is a very important factor as we look at sport and also as we look at our clients in rehabilitation and our students in our physical education classes, so that we could either increase the uncertainty for our opponents, as in competitive kinds of events, or we could reduce the uncertainty for our clients when in fact the uncertainty may cause too much information or tax the system in such a way that the client could not respond in appropriate ways. So, some of the ways that we can actually create uncertainty is through a choice reaction time paradigm. You'll note that on this slide, I'm referring to the number of possible alternatives as choice reaction time because you know as you increase the number of SR alternatives, that increases the choice reaction time paradigm. So the first way that I could actually increase uncertainty is by increasing the number of stimuli. As I go from 2 to 3 to 4 to 8 to 16 stimuli, I increase the uncertainty in the paradigm. In other words, I increase the number of bits of information, and the performer actually has more uncertainty than when there are less or fewer SR alternatives. Also, I mentioned in lab or lecture last week that varying the probability of occurrence would be also a way to increase uncertainty in the paradigm. In other words, if I had 4 SR alternatives, I wouldn't want to give each of these alternatives 25% of my attention. In other words, an equally likely probability of occurrence. Rather, what I want to present is an unequal probability of occurrence so that one of these SR alternatives may show up 50% of the time while the other SR alternatives show up for a lesser likelihood of occurrence, possibly 10% of the time. A good example of this would be in basketball. 50% of the time I may do my layup from the right side of the court, but 25% of the time I'm going to go from the left side, and 25% of the time I'm going to come up from the middle of the court. You could see how I'm varying the probability of occurrence there, and that actually throws my opponents off. The other thing is sequential dependencies. In other words, in all of the examples that I've given you with regard to reaction time, you'll note that the reaction time key is generally located under the light that is associated with that key. In fact, I could change up what key is associated with what light. When there is good sequential dependency, in other words, when that key lines up with the light, I should have less uncertainty and a shorter reaction time than, in fact, when the key doesn't line up with the light. The other thing that affects uncertainty is our ability to predict. And you'll note that I have 4 different types of uncertainty listed here: temporal uncertainty, spatial uncertainty, event uncertainty, and perceptual uncertainty. Temporal uncertainty has to do with the timing of your movement. If I could change up the timing of my movement, for example, how Steph Curry dribbles, he doesn't always dribble with the same tempo. Rather, he changes the tempo during the timing of a single dribbling event. And so it's very hard to predict the timing that Steph Curry is going to use in any particular event. Spatial uncertainty relates to where something is going to occur in space. So again, Steph Curry is not going to shoot from the exact same place on the floor for every shot. Rather, he's going to choose different places on the floor for different shots. Event uncertainty relates to what event is going to occur. An example of this kind of uncertainty would be increasing the number of SR alternatives. So if I am an expert player, I have a better chance of increasing the event uncertainty for my opponent than if I'm a novice player and I only have a few movement patterns that I could attempt to present to my opponents. And finally, perceptual uncertainty, which is really one of my favorites. What perceptual uncertainty relates to is the ability to be able to mask what you're doing so that the perception of your opponent is uncertain. In other words, until the very last moment, my opponent cannot predict what I'm going to do because I mask the SR alternatives in a way that makes everything look almost the same. So I want you to make sure that you go out to this video on perceptual discrimination. It's one of my favorite videos because it has Mariano Rivera, who is maybe the greatest closer of all times. You're going to hear that on the video. For those of you who don't know him, he was a Yankee, of course, and Mariano Rivera would only come in for 1 inning a game, and he would close the game. And you'll see from this video why he was so effective, because he actually increased the perceptual uncertainty for his opponent by making the discrimination of his SR alternative so difficult to detect the difference between different pitches. So go out and watch this video. Both links will bring you there. Finally, today in our slide set, we're going to look at something called the psychological refractory period. The psychological refractory period is the same as the fake. And what it means is that two signals are presented in succession. And really what it means is that it is the time that it takes to recognize that a fake has been delivered, to respond to that fake, and then recognize that a second stimulus has been given and that second stimulus is actually the real stimulus. So if you remember when we talked about the dead space, that point at which you're stuck in one SR alternative before you can actually begin to respond to the second SR alternative. So here you can see a great illustration of the of the psychological refractory period. In this top diagram on the very left here, you can see that this represents no fake. In other words, this would be player A moving to the left, and then player B's reaction time. Notice here, this is the reaction time of player B to the stimulus that's given by player A, and then player B begins to move here. Of course, the stimulus that is given by player A must have a reaction time by player B. The movement would actually begin here. Here on the right side of the diagram, you can see that this would represent player A's movement to the right, different from the first diagram. Again, you have a regular reaction time for player B, and this is where player B's movement begins to the movement of player A to the right. In the second part of this diagram, you can see the illustration of the fake situation. And what you see here is that when player A fakes to the left, you're going to have the exact same reaction time. Here's the reaction time that would exist without the fake situation. Here's the reaction time to the fake to the left. exactly the same as if I were doing the move to the left without the fake. However, I cannot begin to respond to movement B until I have completed my response to movement A. Notice that here is your response to your response to the move to the right, your reaction time without the fake. Notice that this period right here is exactly the same amount of time, but it is added on to the additional time, the psychological refractory period that the subject is stuck in before they could begin to respond to player B's movement to the right. So, some facts about the psychological refractory period is that the reaction time to the first signal is almost always the same as if signal one had been presented alone. The reaction time to the second signal, the movement to the right in this case, is almost always longer. You need to have at least an interstimulus interval. In other words, the period of time between the movement to the left, the fake, and the movement to the right. If it's less than 100 milliseconds, sometimes the respondent or the performer will only respond to one signal. They won't respond to both of them. Practice will not improve the psychological refractory period, and it can only be eliminated if the subject or the performer knows where stimulus 2 is going to occur. Finally, the psychological refractory period is a central phenomenon. In other words, it occurs in the brain. It's a hierarchical issue. It is not a sensory or motor issue. And we know that because even when we give stimuli to do different sensory systems where there should be no interference, or the motor output is to two different limbs or parts of the body, in fact, there still exists this central phenomenon referred to as the psychological refractory period. Remember that this lecture is not going to be contained on your final exam, but for next Tuesday morning, I'm going to put up a pop quiz, and I'd like for you to give an example of each in the real world. In other words, in physical activity, in life, in sport, in everyday life. Can you provide an example of temporal uncertainty, event uncertainty, perceptual uncertainty, and spatial uncertainty? Have a great week, everybody.